So, did you know that when you ask an artificial intelligence a medical question, its rate of hallucination, meaning the percentage of time it just confidently invents totally fake information, can range anywhere from 5 to 20%? I mean, picture having this brilliant new intern on your clinical team, right? They're incredibly fast, but they're dangerously overconfident, frequently just handing you completely fabricated answers because they didn't have enough context. You absolutely wouldn't trust them blindly, would you?
Well, welcome to this explainer. If you're a focused learner looking to safely harness the power of AI in your medical practice, you are in exactly the right place. Today, we're exploring the fascinating world of prompt thinking for clinicians. We are going to learn how to expertly manage this AI clinical copilot, drastically slash those hallucination rates, and the best part, we're going to do it all without writing a single line of code. Here is our roadmap for the explainer today. We'll be looking at 1. The AI clinical copilot. 2. The clear prompting framework. 3. Advanced AI prompting techniques. 4. Real-world clinical applications. And finally, 5. Ethics, privacy, and risks. You are about to add some seriously powerful tools to your digital medical bag. All right, part 1, the AI clinical copilot, moving from autopilot to managed assistant. Okay, let's dive into this. To really get the best out of our digital assistant, we need to fundamentally shift how we interact with it. You know, when we hear the phrase prompt engineering, a lot of us panic a bit and think we're talking about heavy programming or software development. But we aren't. Prompt engineering is literally just the art of structured, persuasive clinical questioning. And honestly, as a clinician, you do this every single day. When you present a case to a colleague, you don't just walk up and say, hey, the patient has a fever. No, you give the age, the gender, the comorbidities, the lab results. Prompt engineering is simply translating that exact same clinical reasoning and structured case presentation into a digital language the AI can actually understand. And the difference this makes is just massive. If you throw in a vague prompt like, what are the causes of chest pain? You're going to get a dangerous 10,000-foot generic guess. But look what happens when you use a specific prompt. You add the age, the comorbidities, like being a diabetic and a smoker, the ECG results, and even formatting requests. Suddenly, the output shifts from a vague guess to a precise, highly structured differential diagnosis. It's a total game changer. Moving right along to part 2, the clear prompting framework, your 5-step checklist for AI communication. So, how do we consistently write these great prompts? Well, the ultimate cure for those AI hallucinations we talked about earlier is the clearer framework. It stands for context, level of detail, expected format, assumptions, and risks. Let's break this down real quick. First, context. Who is the patient? Second, level of detail. Do you just need a quick bullet summary for a busy ward round, or are you looking for a deep, evidence-based explanation for teaching? Third, expected format. Tell the AI exactly what you want. A table, a chart, a one-page PDF? Fourth, assumptions. This is where you explicitly box the AI then so it can't invent things. And finally, risks. Proactively stating uncertainties and setting up guardrails. Now, to really grasp why context is absolutely vital, think about your standard search engine for a second. If you pull out your phone and search for superstar while sitting in Chennai, India, you'll almost certainly get results for the actor Rajinikanth. But if you search for superstar in Africa, the algorithm might actually give you Nelson Mandela. See, the search engine uses over 200 hidden variables, like your location and your network, to guess your context. Medical AI, it doesn't automatically have any of that. Without providing specific context like age, gender, labs, and clinical setting, the AI is just completely guessing in the dark. And that brings us to a critical safety check, which is the A in our CLEAR framework: assumptions. You should literally physically type this exact sentence into your prompts. Do not assume missing data. If you have any doubts, clarify with me first. By explicitly instructing the machine to never assume missing data, you're putting up a massive guardrail. It completely prevents it from confidently generating a fake output just to fill in the blanks. Section 3, Advanced AI Prompting Techniques, Refining the Back-End Settings. Once you've got the CLEAR framework down, you can start doing some really cool stuff. You can actually dial in the AI's clinical reasoning by tweaking its back-end settings. Did you know you can control a model's temperature? Yeah, in the AI world, temperature is just a setting between 0 and 1. If you tell the AI set temperature to 1, it becomes highly creative. Now, that's great if you're writing poetry, but it's terrible for medicine because it leads to super high hallucination rates.
But if you tell it to set temperature to 0 or something close to it like zero point 0.2, it forces the AI to be highly factual, analytical, and strictly stick to the clinical data you actually provided. Alongside temperature, there are 4 advanced techniques you can start using literally today to truly dial this in. First up, role-based prompting. Basically, give the AI a persona. Tell it to act as senior cardiology consultant. It instantly narrows its whole reasoning style. Second, force a structured output. Tell it, provide a 3-column table of red flags. Third, and this is a massive one, step-by-step reasoning. This is also known as chain of thought. Ask the AI to explain your thought process. This forces the machine to show its work, creating much deeper transparency in how it arrived at a specific diagnosis. And fourth, like we just talked about, use guardrail prompting. Tell the AI to ask you questions if the data is insufficient. Okay, let's look at Section 4, Real-World Clinical Applications, bringing AI into the hospital workflow. So how does this actually look in a busy hospital? Well, applying that clear framework transforms AI into this invaluable tool that can save you hours of administrative and cognitive load. Take differential diagnoses, for example. You can feed the AI symptoms like fever and thrombocytopenia in a tropical region, and it will instantly structure a DDX list for you, beautifully categorized by common versus life-threatening causes, like dengue or malaria. Or how about clinical documentation? We all know that's the bane of every doctor's existence. AI can instantly summarize your rough, messy notes into formal discharge summaries. And for patient communication, you can ask the AI to explain a heavy, complex topic like type 2 diabetes using simple analogies perfectly suited for a 10-year-old. And honestly, this next bit is a true game changer for patient communication. The AI can instantly solve communication barriers between doctors and patients from totally different linguistic backgrounds. You can take that simplified explanation of a diagnosis we just made and ask the AI to flawlessly translate it into regional languages like Tamil, Telugu, or Hindi. It literally bridges the health literacy gap in a matter of seconds, empowering your patients to truly understand their own care. Finally, Section 5, Ethics, Privacy, and Risks, the golden rule of medical AI. Now, we have to get serious for a second because all of this incredible power comes with immense responsibility. The absolute non-negotiable point here is this. Standard AI models like ChatGPT or Gemini are public cloud models. They are inherently insecure for private data, they hallucinate fake references, they might be trained on outdated medical guidelines, and most importantly, anything you put into a public AI model is potentially used to train that public model further. The data actually shows a terrifying real-world example of this. A developer carelessly copy-pasted a snippet of confidential code into an AI just to see what it did. Well, the company's firewall caught it, and the very next day they were hit with a 5-crore legal notice for compromising confidential data. Because of that, you must rigorously protect patient privacy. Always de-identify and anonymize your clinical data before typing it into an AI prompt. Never, and I mean never, use patient names, hospital IDs, phone numbers, or addresses. Healthcare data breaches are incredibly costly, both financially and to your professional reputation. You literally have to strip away all personal identifiable information before you even think about hitting that send button. Which perfectly brings us to this great quote from our source material today. AI is a co-pilot, not an autopilot. Remember, you are the domain expert here. The AI does not replace your years of grueling medical training, your intuition, or your human clinical judgment. It's merely a digital assistant designed to help collate data and assist your thinking process. And that leaves us with one final provocative thought. If you use an AI to generate a diagnosis, and that diagnosis turns out to be wrong, who takes the medical legal responsibility? OpenAI? Google? Absolutely not. The human clinician ultimately bears the ethical and legal responsibility for the patient's life. AI is a remarkably powerful tool when managed correctly with strong prompt engineering, but at the end of the day, it is your signature on the chart. Treat your AI exactly like a brilliant but naive intern. Guide it, give it rich context, verify its work, and never, ever let it fly the plane alone. Thanks so much for joining me on this explainer, and I really hope this transforms the way you interact with AI in your practice.